Okay, so in the previous video we showed you how to display your principal components for samples on a chart. We see here clearly differentiated the ER symbols on the left along the PC1 axis, the x-axis, and the TN triple negative samples here on the right, again along that axis except for this outlier on the x-axis. Now we're going to show you how to get the principal components on your genes. This is the important part. We want to identify genes whose represent certain principal components. So we're going to go to our principal components chart here, table here. We're going to ignore the bottom part for now. It just shows our principal components for each of our samples. And I've already selected them, but we're going to copy. Let's do this again. Copy the first two principal components. Now we're going to go over to here, and again we've already shown them. That's just want to show you how to do it, but we've already done all this work. And we're going to paste special. Didn't work there, sorry. Let's go back here and copy it, and then paste special and transpose. And it should do both of them. For some reason it isn't. Let's see if this works. Paste special. Alright, you might just have to do one at a time. It's not working right now. Alright, if you do that. Oh, never mind. Alright, well, it should work with transposition, but of course, as I'm recording, it doesn't want to. And then we're going to do with that. So now we've got them along the other axis, along columns, principal components for samples. And we've already set up, we got PC1, PC2. And so we're going to do a sum product of these values for all the gene expression values for that gene for all the samples. And then over here, you see along in the red, the principal component scores for all those samples for the first principal component. And then remember, what we are going to do if these weren't all filled out would be double click right there, and it'll autofill for us. And make sure you want this to not have dollar symbols, because you want to autofill and fill in for the other rows. But the dollar signs there will tell it, don't change the columns or rows here, we want to keep them. And we will do the same thing for your second principal component, and then we will copy those and put those over into another one, a separate sheet. You're still going to have too many samples if you try to do it. You've got 17,000 genes, so we're going to want to do this. And then we're going to select, do a scatter chart. And here we see clear differentiation between sets of genes here based on the principal component, and we see principal component 1 provided most of the differentiation, principal component 2 doesn't really provide much at all. We're going to choose this outlier as a possible interesting one, and let's add a data label, and that gives us one of the coordinates. And so we're going to copy the coordinate, go back here, and we're going to find it. And it should be pointed out that if you try to use the full coordinate from the graph, it won't find it because it's cutting off your significant digits or the principal components. You can either increase significant digits or just delete a few of these. And we find this gene right here. And you want to collect the gene expression values there, select them, copy, go back to here and do this paste special again and transpose. And I've already done the work here. You're going to have to make separate columns for each of your groups. So make one for ER, one for your triple negative, and your single HER loner gene there, or loner sample. And then this column here will be your sample names. So copy there, or select insert a chart, a column chart, and voila, here we have a bar or column chart showing, again, clear differentiation. We have higher gene expression, or greater principal component load-ins for our ER genes, and lower principal component load-ins for our TN and our HER genes. And this is principal component 1. You can do the same thing with principal component 2, but guaranteed there's probably not going to be much difference. And so that's how you do the component load-ins and how you try to find genes and interpret the data. And in the text, we are going to show you what this gene is.